Sure. Thank you, Harrison. Thank you also to Tess and to Phil and to the rest of the organizers for organizing this day. Like Peter, I'm ringing in from Australia. So I'm hoping to make it as late as lunchtime today. We'll see how I go. I remain optimistic, but it's a great program and I'm really looking forward to the digital. It's a really nice format. So I'm looking forward to that. I also, like Peter, want to acknowledge the traditional custodians of the land where I live, where I work, where this work was done. Those are the Wurundjeri people of the Kulin Nation here in the northern part of Melbourne, on whose unceded lands I live. I want to acknowledge their long history of creativity and knowing with country, a place-based ontology, which is so relevant to all of us as geographers. And finally, to acknowledge their leaders, past, present, and emerging. So my name is Shanti Sumartojo. I'm an associate professor of design research in the Faculty of Design in the Art, Design, and Architecture at Monash universities, but I also sit in the Emerging Technologies Research Lab, which is in that faculty and also in the Faculty of IT. So despite all that kind of hybrid nomenclature, I do self-identify as a geographer, but sort of disguised with all these other labels. I also want to acknowledge the assistance of Daniele Lugli, who helped me with the work that I'm going to present today, which was supported also by a small grant from my Faculty of Art, Design, and Architecture. And this paper is in, it was published earlier this year in Social and Cultural Geography. So this is the highlights with pictures. Okay, so the visible utility of robotic technologies has been significantly boosted by the COVID-19 crisis, with robots variously proposed or used for delivery of food or medicine, hospital sanitization, information sharing, or surveilling people for signs of illness. So in this paper, I'm going to explore how robots have been designed and deployed to address some of the shared challenges of COVID-19. And in doing so, I'm going to propose a framework for thinking about robots as lively, based on their examples of their use during COVID-19. And as you can see in this slide, there's a few different applications there. And I'm going to argue that this can help us address the challenge that Vincent Del Casino identified way back in 2016, that identifies the emergence of robots as caring subjects. So a few organizing concepts that underpin the analysis. First, the notion of liveliness in Deborah Lupton's characterization of data. Here, data is lively because it comes to matter as a result of the effective and bodily aspects of its creation and use, its potential effects on bodies, and its movement and fluidity as it's put to use. An example of such liveliness can be found in self-tracking devices, which is one of the areas where Deborah's done lots of work, where people come to know their bodies in terms of data that they make when they record, for example, an exercise session, the timings of their periods, their heart rates, all these sort of different applications. As Deborah puts it, these devices are assemblages of flesh, data, technology, space, time that are dynamic and shifting as people move through their days and traverse different spatial domains, possessing lively capacities that encourage us to act and think of ourselves in certain ways. So the point here is that machines, people, and their environments all assemble dynamically to compose data that is lively in the conditions of its creation and also in its ongoing use to understand and modify or control the human body. So we bring this together in the paper with Bennett's arguments about vibrant matter. These hinge on a treatment of things as entangled with other things and human and non-human organisms that assemble to extend the agency of matter. Oh, hang on. So Bennett's account of vibrant matter conjures objects as things or vivid entities not entirely reducible to the context in which human subjects set them. She defines thing power as the curious ability of inanimate things to animate, to produce effects dramatic and subtle. So Bennett's vital materialism is also concerned with the agential capacities that inhere in these relations. That is, agencies not inherent to the thing the person or the machine or indeed the virus, but instead resides in how things and people dynamically come together with each other in their environments. However, at the same time, agency is not limited by the assemblage. That is, the force of things may exceed the conditions of their liveliness, generating unexpected and perhaps even wondrous effects. So these conceptual threads weave together in distinct ways when we consider the liveliness of robots during COVID-19. And in particular, I'm going to talk in the bulk of the paper about the three angles that we focus on. Robots as smart and autonomous, robots as inorganic bodies, and robots as unfinished. So I'll start with robots as smart and autonomous. And this is an image of the Pepper robot, which I'll talk about a little bit, which is a humanoid social robot that's used in all sorts of different applications. So as you well know, probably better than I do, smart technologies are typified by embedded digital technology for data collection, network connectivity, and enhanced control. Definitions of smartness also draw on ways of gathering, recognizing, and responding to a wide variety of cues in the humans that encounter them, such as interactive speech interfaces like Siri or Alexa. And indeed, Pepper has also speech recognition capacities. So in terms of robotics, this technology supports the advancement of so-called social robots, such as Pepper. With these machines, the goal of roboticists is to engineer companions who eventually, they hope, will be able to truly understand human emotions and take action accordingly and autonomously. And here I draw inspiration from Yolande Stringer's and Jenny Kennedy's recent book called The Smart Wife, which I highly recommend. One immediate context for such applications is that of care, such as hospitals, residential care settings, childcare, or in homes, domestic settings, for example, to support aging in place. So these examples of smart technology reinforce Delcassina's provocation that robots might be implicated in relationships of care, and indeed in the development of social robots is partially animated by this aspiration. However, coronavirus revealed that robots' limitations in terms of their smartness, autonomy, and social interactions were not actually the most urgent problem to be solved. Indeed, COVID showed us that we do not require robots to be that smart to perform the jobs that we really needed them to do during the pandemic, such as delivery, disinfection, and spatial distancing that the pandemic demanded. So for example, one growing area of robot use has been in the delivery of food or other small parcels. With mobility restrictions and the fear of virus transmission through human contact, delivery vehicles like KiwiBot, which you can see in the top left corner there, have become increasingly common. Indeed, during the social distancing and commercial shutdown during the pandemic, there's been a big demand for their service. However, these robots are not autonomous as they appear. Kiwi delivery robots in the United States are supervised by remote workers, as this article refers to, in this case in Colombia, who monitor them every 10 seconds and who can take over their controls if necessary. And then the bottom left there, there's a animation of the kind of interface that the robot monitors can see. So imagine looking at 10 of those, checking every 10 seconds. In this example, the apparent autonomy of robots actually relies on the ghost work, as Gray and Suri call it, of humans hidden from view. So we're getting a complex version of care emerging here. Okay, so if that kind of unsettles or sort of problematizes the notion of robots as smart and autonomous, the second point that I want to make here is about robots as inorganic bodies. So the COVID-19 highlighted particular aspects of robots as mechanical bodies. It foregrounded the materiality of the robot body and its impermeability to an organic virus. Robots can't get ill, die, or become distressed by exposure to a pathogen. Robots' capacity to spread or limit the spread of that contagion differs from human vectors. They might carry the virus on metal or plastic exteriors, but these can be easily disinfected. Finally, they can limit the contact between different human bodies, for example, by delivering essentials or reminding people in shared spaces to adhere to social distancing guidelines, as we saw, for example, in the use of a Boston Dynamics spot robot in Singapore. In these ways, robotic liveliness is made relationally with the organic affordances of human bodies, both in their bodily differences, that is, bodies that cannot be infected, for example, but also in their similarities, in other words, the ability to perform some tasks usually performed by humans. So the best examples of how robotic bodies demonstrate their inorganic liveliness comes from their application in health service. So even before the COVID pandemic, they moved food and other supplies around busy hospital precincts. And during the pandemic, they started to be used for things like providing basic health information, and telepresence of doctors and family members for quarantined or contagious patients. And this is, in this image, this is the Tommy robot in Italy, which was used to help people maintain contact with their families when they were in quarantine. So here they were a viable alternative to bringing doctors and visitors closer because they were not at risk of getting sick themselves. And they could also be readily disinfected. Accordingly, robots made forms of care possible because of their bodily differences from humans. Although some activities, such as cleaning or presence as a patient's bedside, would normally have been human ones, they help to reconfigure the response to COVID-19 by adding new capacities to the caring assemblage. This does not mean that they provided care in the same way as people, but rather that in settings where staff were overstretched or becoming ill themselves, they made possible particular responses to the threat of contagion. Their liveliness, in other words, emerged in ways related specifically to their inorganic bodies, as they enacted distinctive forms of agency in the context of the pandemic. Okay. So my final point is about robots as unfinished technologies. So robots that are designed for completion by their users are not uncommon. And in fact, many are designed specifically as customizable platforms, such as the Pepper robot that I showed at the beginning. In this example, during COVID, food delivery robots like this Neuro were repurposed to deliver medicine protective gear, such as masks, hand sanitizers, test kits, samples between hospitals. And you can see in the top right, that's a US pharmacy chain. And so these Neuros were also developing people's prescriptions. And in fact, when you Google the Neuro, you get images of like repurposing during COVID, and also lots of pizza delivery images, because that's what they were being used for before the pandemic. The KiwiBot that I showed you before developed a fumigator attachment to help disinfect the robot's surroundings as they moved. And this was really useful during the pandemic when rapid redesign was required and human users didn't have ample time to learn how to operate a new technology. So here, robots could be turned to new applications as needs changed. So COVID-19 has shown us precisely how the unfinishedness of technology offers opportunities not only for improvisation as a valuable mode of technology development and use, but also for imagining what might come next. That is, as people turned existing platforms to new uses, it opened up possibilities to even think about what else these technologies might be used for, right? So this speaks to the dynamic assemblages in which robots are active, but never quite completed. In terms of the possibilities of robots as caring subjects, the unfinished thing force, in Bennett's words, of robots and the effective potential of their liveliness, as we framed it, highlights how forms of care and caring might emerge through ongoing robotic relationalities, including with people, environments, and other technologies, rather than be determined in advance through design processes. And this is important because often robot designers and developers want to design a solution that will be able to go into an environment and perform perfectly in that environment, right? And address the sort of perceived need. But what we're saying is that if you think of if you think as robots as sort of as part of a continually emerging caring assemblage, then you start to find out much more interesting things about the capacities, the agential capacities of the robots themselves, but also of care as something that's emerging and where technology can play a really interesting and ongoing role. Okay.
Thank you very much, Shanti. That was in perfect timing, might I also add. That was great. We have a bit of time for questions.
I do have one more slide here.
Do you have one more slide? I'm so sorry.
I do, yeah, that's all right.
Okay.
I'll bring it all to a stunning conclusion, I promise.
Okay, thank you.
To grapple with their role in an ongoing and emergent world, David Bissell and Vincent Del Casino proposed robots as emergent assemblages more than stable entities by focusing on the materialities, of specific and contingent human-machine interfaces. So in this paper, we've taken inspiration from this and suggested a framework of robotic liveliness as a property of this emergent assemblage in which ongoing relations with humans are crucial. Robotic capacities and settings of care have quite rightly been problematized because some applications seek to replace human labor rather than augment or extend it. However, we contend that it's precisely robots' lively, relational, and unfinished technological entanglement with people that carries the potential to position them as contributing to care rather than somehow supplanting human labor. We suggest, therefore, that the implications for care could relate to where liveliness might be located, and the different approaches we've discussed here suggest multiple or composite locations. Liveliness is as much in the systems through which the data moves, as Louisa Moore identifies in her class, as it is in the apparently autonomous bodies of robots. It's as entangled with the programming and engineering from which robotic functions emerge, as it is with the streets and buildings where robots roam. Liveliness plays across the vectors we've outlined above, and robots' ongoing and unfinished quality means that liveliness itself is not settled and cannot be thought of as constrained to one location. The many growing uses of robots and the accompanying concerns and aspirations about them demand the continued advancement of robot geographies that can account for these technologies and help to play a role in the trajectories of their development. And now I really am finished, Harrison. And this is the website of the, that's all right. This is the website of the bigger project that the paper sits within.